Drawdown refers to the point in time when greenhouse gas concentrations in the atmosphere begin to drop on a year-to-year basis. Paul Hawkins' Project Drawdown popularized the idea by focusing on 100 solutions to the climate crisis involving the reduction, sequestration, or removal of greenhouse gases, with an emphasis on carbon dioxide. Indeed, 98% of today's mitigation funding goes to projects which exclusively or primarily target carbon dioxide. Implementation of such efforts is crucial in the battle against climate change. However, because CO2 is so long-lived in the atmosphere, it will take decades for such solutions to measurably slow the rate of increase in atmospheric concentrations, as emissions mount up and accumulate each year. Even if we were to halt new emissions of carbon dioxide altogether, annual emissions in the tens of billions of tons are only a fraction of the trillion-plus tons already in the atmosphere. Meanwhile, despite global efforts to date, the pace of climate change is accelerating. In its 2018 Special Report on Global Warming of 1.5 degrees, the IPCC stated bluntly that the Earth could reach the 1.5 degrees Celsius global temperature anomaly threshold as early as 2030. No wonder 2030 has become the rallying cry for millions around the world. As a result, we need a near-term bridge strategy to help us buy time before longer-term CO2 solutions kick in. Among the most important steps we can take is to draw down emissions of short-lived climate pollutants, three in particular: methane, black carbon, and tropospheric ozone. This bar chart illustrates the relative climate footprint of countries in 2015. Each bar includes not only the annual GHG emissions included in a typical carbon footprint, but also the portion of GHGs emitted in prior years that were still in the atmosphere in 2015. Each bar also includes short-lived climate pollutants, which are typically left out. This gives us a more complete picture of the problem and points to solutions. The vertical y-axis is expressed in watts per square meter, that is, radiative forcing. Radiative forcing is the underlying metric climate scientists use for all climate forcers, long-lived or short-lived. Here, blue stands for carbon dioxide, black for black carbon, red for methane, yellow for nitrogen oxides, a precursor to tropospheric ozone, and green, the other greenhouse gases. As you can see, in the US and other industrialized countries, about 2/3 of our footprint is carbon dioxide, most of which has been accumulating for decades. Annually, black carbon, methane, and tropospheric ozone represent a substantial and growing part of this footprint. In the developing world, by contrast, these three short-lived climate pollutants constitute half or more of the total climate footprint. See China, India, Indonesia, and Brazil. The sources of these short-lived pollutants vary by country. Black carbon comes from industrial sources, coal-fired plants, brick kilns, two-cycle engines like leaf blowers and chainsaws, diesel trucks, cooking fires, agricultural burning, land clearing, and deforestation activities. When black carbon particulates land on ice and snow, it accelerates melting, exposing darker surfaces and reducing the Earth's albedo, its ability to reflect the sun's radiation. Methane pollution is from industrial sources like oil and gas production, from livestock and other agricultural activities, and from landfills. Tropospheric ozone is connected in part with methane and in part with tailpipe pollutants and other sources that combine to form ozone and smog. For virtually all of these short-lived climate pollutants, there are ready-to-go, off-the-shelf solutions, often at pennies to the dollar for mitigation, an attractive strategy, especially for countries with limited resources where these emissions dominate. And because short-lived climate pollutants are extremely potent ton for ton compared to carbon dioxide, drawing down these emissions can have a dramatic near-term benefit. There are co-benefits as well, including cleaner air quality to protect the lives of millions. To conclude, drawdown must include the short-lived climate pollutants as well as long-lived greenhouse gases. And we must have a 2030 strategy if we are going to keep the global temperature anomaly below 1.5 degrees Celsius. Thank you.